Okay, let's go ahead and do this. This is homework number 6 for chapter 3. We're going to be working on area model, trying to find the area as a product and trying to find the area of sum. Got to be careful a little bit on this. The directions is a little backwards, so area as a product. So that means that we want it to look like this. Okay, so this, they wrote it backwards. And area as a sum is basically the stuff that's on the inside. Right? And because we're a little short on space, I'm going to be putting my length on along the top, right? So when I'm going to do this, I'm going to write my area as a product. Notice how we have x to the third. That's the only thing by itself. So that right there is going to go on the side. So I'm going to put x to the third because there's no other space for any other term. And then I'm going to go ahead and put the 4x squared plus 5x plus 1 along the top. Okay, or the bottom, but I don't have space on the bottom, so I'm going to put it along the top. So 4x squared plus 5x plus 1. And I'm trying to keep my pluses and minuses in between where the line is, just to help with the separation. Right, so to do the work, I have to multiply x to the third, which is the length of that, times 4x squared, which is the length of that. So that's going to give me 4x to the fifth. Okay, so if I'm doing the next one, if I'm doing the next one, I need the length of this, which is x to the third, times the length of that, which is 5x. So x to the third times 5x is going to give me 5x to the fourth. Okay, then I move on. I need to find out the length of this, which is going to be x to the third, and then the length of this, which is 1. So x to the third times 1 makes 1x to the third. Or if you want, you can just call it x to the third. Okay, all right. So my area as a product is going to be, let me just refix this, rewrite this. Area as a product is going to be x to the third. Okay, and I'm going to put parentheses just because that's how I was showing you guys. And then if you don't want to put parentheses, I'll show you what it looks like. Just take it off. And then times it by um, 4x squared plus 5x plus 1. Okay, and you can do like that. Okay, and again, if you don't want the parentheses, which makes it look a little cleaner, you just remove the parentheses. And guess what? It looks exactly like how we started. Right? So most of the time you see it just like that. So it's x to the third. This area is the product. That's one of the product, one of the factors, and then 4x squared times 5x plus 1 is the other. Right? And the area as a sum is basically all the areas of the inside added together. So we're going to have 4x to the fifth plus 5x to the fourth plus x to the third. Okay. Right, so basically knowing what we know now, area as a product is basically just these two right here. The length times the width. So we have x plus 2 and 3x plus 1. Okay, so I'm just going to go ahead and write it. X plus 2, and because I'm a little short on space, I'm not going to be writing it down here. And I'm going to, so 3x, I'm going to put up here. And it really doesn't matter where you put it as long as you put one along the vertical, so either so up and down, either one of those, and you put one along the horizontal, either that one or that one. So it doesn't matter how you do it, just you got to make sure you do one of each, right? And then I'm going to go ahead and do the area as a sum, right? So this right here, this is x times 3x. And that's going to give me 3, and notice that you have an x and then another x, so that means that you're going to have x squared. Okay, this next one down here, this is 2, and then times that amount, right? 2 times that much, and notice that this is the same as that, which is the same as that, which is 3x. So 2 times 3x is going to give you 6x. Okay, and you want to know how much is over here, that's going to be the same amount, so that's going to be x. So that right there is x, and that right there is -1. So 6 times -1 is negative, excuse me, x times -1 is negative x. Okay? Or if you want, you can call it negative 1x. And the last one, the last square is going to be, that's -1, so that's -1, and that's -1. And then this right here, this is 2, so that's 2, and that's 2. So -1 times 2 is going to give you -2. Right, so your area as a sum is going to be, excuse me, 3x squared plus 6x, and I'm only going to do this once, minus 1x minus 2. And if you notice that 6x and negative 1x, that's going to combine to be positive 5x. So instead of 3x squared plus 6x minus 1x minus 2, I can write this as 3x squared plus 5x. If you're not sure about how to add or subtract, go ahead and use a calculator. Yeah, and then minus 2. Oops. That's not good. Okay, so again, I'm going to take advantage because I already have that set up as a area as a product. This is going to be 2x plus 5 and 4x minus 10. Okay, that's area as a product. I'm going to go ahead and just write it along the vertical, 2x plus 5 and 4x minus 10. Okay, let me go through and do the work. 2x times 4x, we're going to talk about what's in here. 2x times 4x is going to give me 2 times 4 is 8. X times x is x squared. Okay, then I try to figure out what goes in here. Okay, that's 5 times 4x. So 5 times 4x is 20x. Okay, and I'm going to look at what goes in here. That's 2x times negative 10. Don't forget about the minus. So 2x times negative 10 is negative 20x. And then lastly, I'm going to find out what goes in here. That's going to be 5 times negative 10. That's going to make negative 50. Okay, and in here, you will notice that there are certain terms you can combine, like for example, 20x's and negative 20x. And those are definitely gonna cancel each other out. Right? So basically 20x minus 20x is gonna be 0x's. So at the end of the day, I will only have 8x squared minus 50. Okay. Next one. Again, I already have my product. So 6x minus 1 and 3x minus 1. Okay, I'm going to go ahead and write this along the side. Okay, and let's just go ahead and do the side. Right, 6x minus 1. Okay, or if you want, you can put a plus a negative 1 if you want to. If you want to feel like you want to put the minus next to the 1. Right, and I'm going to put a 3x. I'm going to write it this way: 3x. Okay, plus a negative 1, just to show that we can do that. Okay. So you can put it any way you want. Just make sure that the symbols are correct with your terms. Okay. And you're going to go ahead and multiply them out. So 6x and 3x. So we're looking at what goes in here. So 6x times 3x. That's going to get you 18x squared. So that's 18x squared. Next, we're going to figure out what goes in here. So I'm just showing you different ways that you can take into account what you've done. All right. So 3x times negative 1. 3x times negative 1 is in negative 3x. Okay. Then we go ahead and figure out what goes in here. Okay. And that is a 6x times negative 1. That makes a negative 6x. And lastly, we have this. That right there is a negative 1 times a negative 1, which makes a positive 1. Okay, so what do I have? I have all of this, but there are certain things that I can combine. For example, this negative 3x and a negative 6x, I can combine those. Okay, so that's going to be negative 9x. And then I have the 1 by itself, which is a positive 1, by the way. I think that looks pretty cool. All right, that's the first page. Next page is on graph paper, graph each of the lines below on the same set of axes. Down below, what is the relationship between lines A and B? What's the relationship between B and C? All right, so line A, I will put that in red. Okay, and we will start with positive 4. The y-intercept is right here. So positive 4. 1, 2, 3, 4. And the slope is right here, which is up 1 and over 3. So up 1 and over 3. 1, 2, 3. Okay, it looks like 4 points, but if I go up 1, okay, I'm up 1 only. I haven't gone over yet, so I have to go over 1, over 2, and over 3. So that is correct. Okay, and then I'm going to go ahead and use a ruler if you can. Use a ruler if you cannot. It's okay. And you're going to go ahead and draw your line. Make sure you draw arrows at the end of that. So that's my line A. I'll put A right there. Okay, line B, I'll put that in green. That's positive 4 again. So we're going to start at the y-intercept, positive 4 right there. And this slope is right here, negative 3 or negative 3 over 1. Because you know negative 3 can be counted as negative 3 over 1 because we do need the change in the y over the change in your x. So the change in y is going to be down 3. So down 1, down 2, down 3, and then over 1 right there. So again, I'm going to use my ruler. About right there. I'm going to draw my line. Okay, this line is going to look like this. Okay, and lastly, this one's going to be my blue line. Oh, let's call that B. Lastly, my blue line, that's C. The y-intercept is going to be negative 2. So I'm going to start at negative 2. And the slope is going to be negative 3, which we already saw. I did that earlier. Negative 3 really means negative 3 over 1 for the change in y over change in x, right? So I'm going to start at negative 2, and then I'm going to go down 3 and over 1. So negative 2, I'm going to go down 3, 1, 2, 3, and then over 1. And then I'm going to go ahead and graph Same thing. Okay, that's my blue line. Okay, and that right there is going to be my line C. So first thing is, what's the relationship between line A and B? So you look at line A and B, right? Or, which is the red and the green. And let me just take out the blue line for a second. Right, red and green, if you look at red and green, it looks perpendicular, but we got to double check it. Okay, we got to double check it. So, right, so to double check it, all you have to do is look at the slope. So the red, the line, the slope of the red is 1/3, or m equals 1/3. And for the green, the slope is -3/1. So first thing to check something's perpendicular is, are they opposites? Is one positive, one negative? That's a yes. Second thing is, are the fractions flip of each other? You look at 1/3 and 3/1. So that's a yes. So now that when we look at line A and B, which is the red and the green, we can now say that these are perpendicular to each other, meaning you can draw a right angle right there at the corner. Right? So I can say line A and B are perpendicular. Okay? You know why? Since the lines have opposite and reciprocal slopes. Okay? So, part B, what about the relationship between B and C? You look at B and C, they're green and blue. So if I look at it, I'll take out the red one for a bit. B and C, look at B and C, right? Red, green, and blue. They look parallel. Okay, so I'll put the red one back. But one thing to figure out is take a look at the slope for B and C. Right, so B is already right here, and C, the slope is right here also. -3 means that the slope is going to be -3/1. So therefore, you look at the slope, they're the same in both ways. So you can say line, or lines here, let me put S here, lines B and C are parallel. How do we know that? Well, since the lines have the same slopes. All right. Okay, and I think that is it. All right. See you next time.